My beautiful people, welcome back to my channel. Let's take a look at the problem on the board. We have this Quartic polynomial from Cambridge University entrance exam, s squared plus parenthesis open 2x upon s plus 2 parenthesis close all squared equal to 5. Now, I wouldn't want to expand this because that's going to take longer time. Instead, I'm going to use algebraic substitution. So I will say let y equal to 2s upon s plus 2. So this implies that s squared plus y squared equal to 5. We call this one equation number 1. Then, from y equals 2s upon s plus 2, if I cross multiply, we use y to multiply s plus 2, that will give us sy plus 2y equal to 2x. I will make sy the subject here. That's going to give us sy equal to 2s minus 2y. So I will square both sides of this. That's going to give us sy whole squared. If I square this, that's going to give us 4s squared plus 4y squared minus 8sy. Okay. Then I'll try to factor out 4 here because we already have s squared plus y squared equal to 5. So I'll write sy whole squared equals 4 s squared plus y squared minus 8sy. So can you see the progression? Very easy. So s squared plus y squared is equal to 5. I will have sy whole squared equal to 4 multiplied 5 minus 8sy. Now, 4 multiplied 5 is 20. So this will be sy whole squared equal to 20 minus 8sy. So it's actually a quadratic equation in sy. So I will rearrange this in the standard form. So this becomes sy whole squared. I'll take everything on the right to the left. I'll have it plus 8sy minus 20 equal to 0. So I'm going to factorize this directly. So this will be sy minus 2 sy plus 10 equal to 0. Now, using the zero product property, it implies that sy minus 2 equal to 0 or sy plus 10 equal to 0. So we are going to be having two answers for xy. So sy equal to 2, then sy equal to negative 10. Those are the two values for xy. Now, should have named this equation number 2. This equation number 2, I will say from equation 2, we know that sy is equal to 2s minus 2y. So when sy is equal to 2, we are going to be having 2s minus 2y equal to 2. Okay? So s minus y equal to 1. If you divide both sides by 2. Then we know that sy equal to 2. So we are going to solve these two equations, simultaneously. From here, this is more like case 1. Okay, let's just proceed. You can know that y, if I take y this way, I'll take 1 to the left. That becomes s minus 1. Then I will plug it here. That becomes s into s minus 1 equal to 2. Okay? With this, we've done well. We distribute this parenthesis. Then we move on. It's a very simple problem and straightforward. So s multiply s, that's s squared. S multiply negative 1, negative x equal to 2. So this is going to give us s squared minus s minus 2 equal to 0. It's another very straightforward quadratics. I will also factorize it. That's going to give us s plus 1, s minus 2 equal to 0. So this implies that s equal to -1 or s equal to 2. So we've obtained our first pair of values for x. Then okay, let me say case 2 now. I omitted that. That's not much of an harm. So we know that sy is equal to -10 and sy equal to 2x minus 2y. So if I equate this, I'm going to be having 2x minus 2y equal to -10. So if I divide both sides by 2, I'll be having s minus y equal to -5. So I would like to make y the subject because we're actually solving for x. Okay, if I take y this way, I'll bring -5 this way. It's better like this because I'm trying to avoid negatives. So if I take y this way, it becomes positive, 5 this way becomes positive. That's s plus 5 equal to y, which means that y equal to s plus 5. No harm, no foul. Now, if y is equal to s plus 5, we'll plug it into this equation, sy equal to -10. So we are going to be having s multiply y, which is s plus 5, equal to -10. So if I distribute this, this is going to give us s squared plus 5s equal to -10. I'll come this way. So if I rearrange this again, this is s squared plus 5x plus 10 equal to 0. So this cannot be factorized. I have to use a formula. So s will be -b plus or minus b squared minus 4ac upon 2a. So a is 1, b is 5, then c is 10. So s will be -5 plus or minus. So will be 5 squared, minus 4 multiply 1 multiply 10 all upon 2. So s will be -5 plus or minus 25 minus 40 upon 2. So that will be -5 plus or minus the square root of -15 upon 2. Now, -15 does not have a square root, so I can write this to be negative. Okay, let me bring it down. So s equal to -5 plus or minus square root of -1 multiply the square root of 15 all upon 2. Now the square root of -1 is iota. That's going to give complex solutions. So we're having s equal to -5 plus or minus rad 15 iota upon 2. So of which our two values of x is going to be s equal to -5 plus rad 15 iota upon 2, or s equal to -5 minus rad 15 iota upon 2. So if we were to write this, I can say s equal to 1 upon 2 -5 plus rad 15i, or 1 upon 2 -5 minus rad 15i. Imagine this space here. Okay, bring it down. That's equal to 1 over 2. Okay, let me take the negative out. I'll be having 5 plus rad 15 iota. So guys, these are the two values of x from this second part of the problem. Now we also know that s equal to -1 and s equal to 2. So these are the 4 values of x that satisfy the equation. Please ensure you give this video a like and make sure you subscribe so that you wouldn't miss out in our next video. See you next time.